Good morning, my dear students of first secondary. Today we are going to take a new lesson in algebra. This lesson is called solving a system of linear equation by using Cramer's rule. Let's go. First, we are going to find the area of the triangle by using determinant. Our first lesson will be finding the area of a triangle by using determinant. One of the uses of the determinant in this year is to find the area of the triangle, okay, and to prove that we have three collinear points. Let's take an example on the two cases. Okay, example 5. Find using determinant the area of the opposite triangle whose vertices are x coordinate 1 and 2, y coordinate 3 and negative 4, z coordinate will be negative 2 and 3. Here in this problem we want to find the area of the triangle if we know the vertices of this triangle. But in this way we are going to use the determinant. So how we can find the area? Solution. Area of triangle will be equals to half the positive value of the determinant. Half the positive value of the determinant. How can we write this determinant? In the first row we are going to write x, the coordinates of x, 1 and 2, and in the second row we are going to write the coordinates of y, 3 and negative 4, and in the third row we are going to write z coordinates, which is negative 2 and 3. But we all know that the determinant must be a squared matrix, so it is 2 by 2 matrix or 3 by 3 matrix. So how we can make this determinant is 3 by 3 determinant. So we need to write the first column, the last column or the third column by 1, 1, 1. Okay? Okay. Then we are going to find the value of the determinant. We will write the determinant 1, 3, negative 2, 2, negative 4, 3, and 1, 1, 1. Then we will write the element of the first two columns, again, the first and second column, 1, 3, negative 2, 2, negative 4, and 3. Multiplying the left diagonals together, okay, minus the right diagonal. So it will be half multiplied by 1 times negative 4 times 1, it will be equals to negative 4. 2 times 1 times negative 2, 2 times 1 times negative 2, it will be equals to negative 4. And the last one will be here, this is the second diagonal, okay, and this is the third diagonal. 1 times 3 times 3, it will be positive 9. Okay, this will be minus the product of the right diagonals. 2 times 3 times 1, it will be equals to 6. 1 times 1, here, this is the other diagonal, here 2 times 3 times 1, okay, 1 times 1 times 3, it will be equals to 3, and the last one will be 1 times negative 4 times negative 2, it will be equals to positive 8, okay. So this will be equals to half multiplied by negative 4 minus 4, negative 8 plus 9, it will be equals to 1. 6 plus 3, 9. 9 plus 8 equals 17. so it will be 1 minus 17. Okay, so here it will be equals to half 1 minus 17, it will be equals to negative 16. Half times negative 16, it will be equals to negative 8. Okay, here you can see that the area of the triangle is a negative value, so we will write area of triangle equal the absolute of negative 8, which is equals to 8 squared units. Okay, because we don't have an area in negative, so we will write the area of the triangle will be equals to 8 squared units. 8 squared units. Okay, let's go to another example. To prove that 3 points x, a and b, y, c and d, z, whose coordinates are e and f, are collinear by using determinant, we prove that the value of the determinant equal 0. We prove that the value of the determinant will be equals to 0. Okay, so in this example 6, prove using determinants. You can't use any other way. Prove using determinants that the points negative 2, 4, 3 and 0, 8 and negative 4 are collinear. Okay? We need to prove that these points are collinear. So we will find the value of the determinant. First, we write the coordinate of x, negative 2 and 4. Coordinate of y, this point will be x, and this will be y, and this will be z. Negative 2 and 4, 3 and 0, 8 and negative 4. And to make it a 3 times 3 determinant, we write the third columns, the 1 columns. Okay? Write the first column again, write the second column again, 4, 0 and negative 4. Okay, and this is equals to, here we are going to write all the element of the left diagonals together. It will be equals to negative 2 times 0 times 1, it will be 0. 4 times 1 times 8, it will be equals to 32. Okay, 1 here again, 4 times 1 times 8, and the last diagonal will be 1 times 3 times negative 4, it will be negative 12. Minus the right diagonals, 4 times 3 times 1, it will be equals to 12, and negative 2 times 1 times negative 4, it will be positive 8, and the last one, 1 times 0 times 8, it will be equals to 0. Okay, and this is equals to, here we have 32 minus 12, it will be equals to 20, minus 12 plus 8, it will be equals to 20, 20 minus 20 equal 0. Since the value of the determinant A equals 0, so we can say that therefore x, y and z are collinear. So it is very easy to use the determinant to find the area of the triangle, or to use it to prove that we have 3 points x, y, or z are collinear. In the first case, we find half the value of the determinant. Okay, to find the area of the triangle, we get half the value of the determinant whose coordinates are, or whose rows are x, y and z. Okay, and this value must be positive value. And to prove that the 3 points are collinear, we find the value of the determinant. If it will be equals to 0, so the so the 3 points are collinear. If it is not equals to 0, then the 3 points are not collinear. Okay? Let's go to another idea. Solving system of linear equation by using Cramer's rule. Find solving a system of linear equation in two variables. Example 7. Solve the system of the following equation using Cramer rule. Here we have two equations. 6x minus 5y equals negative 23. 3x plus 3y equals 16. Okay? These two equations are linear equation, okay? Or we can say two simultaneous equations. But now we are going to solve this system of linear equation by using Cramer's rule, which means we are going to use the determinant to find the solution of these two equations. Okay? First solution. First, we are going to find the value of delta. Delta is the determinant whose value are 6, here, negative 5, and 3, and 3. Okay? So, delta is the value of the determinant whose contains the coefficient of x and y. Here we have 6x minus 5y, so we write the first row 6 and negative 5. Here we have the coefficient of x is 3 and the coefficient of y is 3. So we will write the value of the two coefficients 3 and 3. Okay? We will find the value of the determinant. 6 times 3 it will be equals to 18 minus negative 5 times 3 it will be equals to negative 15. So it will be 18 plus 15 and this is equals to 33. So this is the value of delta, which is the determinant of the coefficient. Then we are going to find, so this is the first step. The second step is to find delta x. How can we find the value of delta x? By replacing the first column by the coefficient negative 23 and 16. So we will write here in the first column negative 23 and we will write 16. Then we are going to write the values of y as it is. So we have negative 5 and 3. And we are going to find the value of delta x. Negative 23 times 3, it will be equals to, here it will be equals to negative 69 minus negative 5 times 16, negative 5 times 16, it will be equals to negative 80. Okay, so negative 69 negative 80 will be positive 80, so the result will be 11. The third step, that let's go to find it, to find the third step. We will write the determinant delta y. We will find the value of the determinant delta y. So we find first delta, which is the value of the coefficient of x, y. Delta x, we find delta x by replacing the constant negative 23 and 16. We put it in the first column and write the elements of y in the second column. Delta y, here we are going to write the coefficient of x. It will be 6 and 3, and we will replace the y columns by negative 23 and 16. Let's find the value of this determinant. It will be 6 times 16. It will be 6 times 16, which is equals to 96, minus 3 times negative 23. It will be equals to negative 69. So it will be 96 plus 69, and this value will be equals to 165. So how we can find the value of x? Now x will be equals to delta x over delta, and the value of y will be equals to delta y over delta. Delta x here equals 11 over 33, which is equals to 1 over 3. Delta y over delta, it will be equals to 165 over 33, and this is equals to 5. So the solution set is the set whose element is the order pair 1 over 3 and 5. This is the solution set of these two equations by using Cramer rule. Okay? Okay. Let's go and take another example. In this example, we are going to solve the system of the following equation using Cramer's rule. But in this case, you see that we have three equations. We have here three linear equations. So we want to find the solution set for a system of linear equation formed from three equations. In the first example, we have a system of linear equation formed from two equations only. But in this case, we have three equations and we have three unknowns, x, y, and z. Okay? So, in this example, this is a long one, this is a long example, and you have to be concentrated very well. Solution. First, we are going to write each equation in the form of x, y, and z. So we will write 2x first, 2x plus 3y, okay? Z will go to the other side, will be minus z equals 1. The second equation will be 3x, and negative 5y will go to the other side, plus 5y plus 2z equals 8. And the third equation, this is the third equation, we will write it here, x, we have x, minus 2y, negative 3z will go to the other side, here 3z will go to the other side, it will be negative 3z, and all of this equation will be equals to negative 1. Okay? Now we are going to find delta. Delta, which is the determinant of the coefficient x, y, and z. Here we will write 2, 3, negative 1, okay? 3, 5, and 2. And the last row will be 1, negative 2, and negative 3. Okay? Then we are going to find the value of this determinant. Write the elements of the first column, 2, 3, 1. Here 3, 5, and negative 2. Okay? We are going to multiply the element of the left diagonals. 2 times 5 times negative 3, it will be equals to negative 30. Okay? 3 times 2 times 1, it will be equals to plus 6. Negative 1 times 3 times negative 2, it will be also positive 6. Minus the element of the right diagonal, 3 times 3 times negative 3, it will be equals to negative 27. 2 times 2 times negative 2, it will be equals to negative 8. Okay, and the last diagonal will be negative 1 times 5 times 1, it will be equals to negative 5. by using calculator. Negative 30 plus 12, it will be equals to negative 18. Okay, minus negative 27 minus 8 minus 5, it will be equals negative 27 minus 13, so it will be equals to negative 40. Negative 40. So it will be negative 18 plus 40. So the first one will be equals to negative 18 plus 40. And this is equals to 22. Negative 18 plus 40, this is equals to 22. So this is the value of the determinant delta, which is containing the coefficient of x, y, and z. The second step, we will find delta x. We will find the value of delta x. Okay? Here we are going to replace the first column 2, 3, and 1, which is the coefficients of all the x coordinates, and we are going to replace it by the constants 1 and 8 and negative 1. So here we have 1, 8 and negative 1. Write the two columns as it is, 3, 5, negative 2, and negative 1, 2, and negative 3. Okay? Write the value, write the 1 here, write the element of the first column, 1, 8, and the negative 1, the element of the second column again, 3, 5, negative 2. Find the value of the determinant. Okay? It will be 1 times 5 times negative 3 is equals to negative 15. 3 times 2 times negative 1, 3 times 2 times negative 1 will be equals to negative 6. Negative 1 times 8 times negative 2, it will be equals to positive 16. Minus the right diagonals, 3 times 8 times negative 3, it will be equals to negative 72. 1 times 2 times negative 2, it will be equals to negative 4. Okay, and the last diagonal will be negative 1 times 5 times negative 1, it will be plus 5. Okay, this is plus 5. Negative here, negative 15 minus 6 plus 16. Okay, negative 15 plus 10, it will be equals to negative 5. Here we have negative 72 minus 4, it will be equals to negative 76. Negative 76 plus 1, it will be equals to negative 71. Negative, negative, so it will be plus 71. Negative 5 plus 71, it will be equals to 66. So this is the value of the determinant delta x. Okay, then we are going to find the value of the determinant delta y. Delta y. Delta y. We will write the coefficient of x again, 2, 3, and 1. We are going to replace the columns of the y coefficient, of the coefficients of y, by the constant value 1, 8, and the negative 1. Then we are going to write the coefficients of z, negative 1, 2, 3. Okay? Write the elements of the first column, 2, 3, 1, 1, 8, negative 1. Find the value of this determinant. You will find it will be equals to negative 22. So delta y will be equals to negative 22. The last determinant will be delta z. To find the determinant delta z, okay, we are going to write the value of the x, the coefficient of x, 2, 3, 1. The value of the coefficient of y, 3, 5, negative 2. And we are going to replace the values of the coefficient of z by the constants 1, 8, and negative 1. Okay, write the value of the first column again, 2, 3, 1. The second column will be 3, 5, negative 2. Find the value of delta z by finding the multiplying of the left columns minus the multiplying of the right columns. You will find that delta z equals 44. Okay? Now to find the values of the unknown x, y, and z, x will be equals to delta x over delta, y will be equals to delta y over delta, z equals to delta z over delta. Okay, delta x over delta, we get delta x equal 66 and the value of the delta equals 22, so x will be equals to 3. Delta y equals to negative 22 divided by the value of delta, which is equals to 22, so it will be equals to negative 1. Delta z over delta will be equals to 44 divided by 22, and this is equals to 2. Don't forget to write the solution set. So the solution set of the three equations together will be 3, negative 1, 2, which is the value of x, the value of y, and the value of z. Okay, thank you so much. Until we meet again next time, goodbye and good luck.